And we're back. Going on to this one. This one also going to be special. All right, special. You don't know that until you start working it. First thing we're going to do is distribute. We'll get 2x plus 14 is greater than 3 plus 2x. You'll notice I have 2x on one side, I have 2x on the other side, so they balance. If I try to move them, they disappear. This is not a problem. It's not an issue, rather, but it does create a special situation. We look at this, all right, and again, we're going to think, is 14 greater than 3? Well, of course 14 is greater than 3. Will it always be greater than 3? Yes, it will. So it doesn't matter what we put in for x. They're going to cancel out anyway. All that needs to be true is 14 is greater than 3, and we'll be fine. So there's an infinite number of solutions that will work here for x, because it doesn't matter what x is. You could put in a 5, you could put in a 12. Doesn't matter. It's going to cancel out anyway. So we have infinitely many solutions, IMS. That's problem number 15. Problem number 16. Several steps. First thing we want to get rid of this is minus 5. It's easy to get rid of. All I have to do is add 5 to both sides. I will get 2r over 5 is greater than or equal to 8. The next step, divided by 5 here. I want to get rid of that divide by 5. So I multiply both sides by 5. I'm going to get 2r is greater than or equal to 40. Divide both sides by 2. I'm going to get r is greater than or equal to 20. And that'll be my last step on that one. Sliding it up. Sliding it up. Want to get rid of this 30 on this one. Notice we got the negative 8 in here. Do not forget about that negative. Get rid of the 30 first because it's easy. I've got negative 8x is less than. This is going to be negative 24. Watching those numbers, they get a little bit dicey as you go. Going to divide by a negative 8. That's a dangerous move. We're dividing by a negative number. Whenever you divide by that negative number, it's going to flip your inequality symbol. So I'm going to get 8 is greater than positive 3. I'm all done. Watch those negatives. They get a little dangerous. Now, this one. Couple of different ways you can do it. I'm going to show you the way I anticipate most of my students doing it. They're going to take this 1/2 and they're going to distribute it. That's going to give them 3 over 2x plus 3 is greater than or equal to negative 1. So half of 3, half of 6, I've distributed, I've gotten rid of that 1/2. There is another way to do it. You can take the entire equation and multiply it by 2. The dangerous part here is you've got to understand that when you multiply by 2, all you do is eliminate this number on the outside. 1/2 times 2 is 1. It's going to, distribute that 1. You'll get a 3x plus 6 on the inside. And it will go straight to this because you'll multiply that negative 1 by 2. And you'll get a negative 2 over here. So you can go straight to here. I, however, anticipate most of my students taking it this way. So we'll continue from this point. I've got the minus 3 from both sides. I'll have 3 over 2x is greater than or equal to negative 4. At this point, I've got to divide by 2 with my x. So I'm going to multiply both sides by 2. And I will get a 3x greater than or equal to negative 8. Notice I've got a negative 8 over here and I've got a multiplication, but the 2 that I multiplied by was not negative. Therefore, do not need to flip this inequality sign. Only this number will dictate whether or not you flip that inequality sign. Last step. Last step, I'm going to take and divide both sides by 3. I'm going to get a fractional answer, which is just fine. X is greater than or equal to negative 8 over 3. Do not be tempted to throw that bad boy in your calculator and get negative 2.67. It's not necessary. Looks better as a fraction, I think, anyway. Go into this one. Translate into an inequality, then graph. All numbers less than or equal to negative 4 or greater than 8. So, big one, I want x to be less than negative 4. I'm going to go ahead and throw that on there because it's got the or. Either one can be true. Less than or equal to 4. So it's going to be filled in. Or greater than 8. So here's 8 over here. Or I want x could also be greater than 8. So there are two types of numbers that could fit. You can either be really small or you can be bigger than 8. Either one is going to work because of that or. Headed on to the next page. Write and solve find the possible values. Formula for perimeter. We're going to get, 2 lengths plus 2 widths is equal to perimeter. The inequality, you will have 2 lengths, and we will say the length is the x plus 4. So we have 2x plus 4s. And our widths, we have 7. And we want this to be, the minimum is 28. So it needs to be bigger than or equal to 28. That is the minimum. So the solution, I'm going to do a little bit of work over here. We're going to distribute the 2. And I'll get a 2x plus 8 plus 14 needs to be greater than or equal to 28. My next step, probably going to want to push those two together, so I'll get 2x plus 22 greater than or equal to 28. My next step, subtract the 22 from both sides. 2x needs to be greater than or equal to 6. So x needs to be greater than or equal to 3 once we divide that 2 off and get our final piece. So x needs to be greater than or equal to positive 3 for this to work. Sliding it up. Solve the compound inequality. This is where it gets a little dangerous, all right? Especially on the ands. We want to get this x by itself. It currently has a minus 4 on it. Just like we would anywhere else, I'm going to add 4. The difference, there are 3 pieces to this equation. So if you add 4 to one side, you've got to add 4 to all of them. It's like if I have 7 is equal to 7 is equal to 7. If I change one of these numbers to 8 by adding 1, the only way to keep them all the same is to do it to each piece. So when we add 4 to here, got to add 4 to the other pieces. And that's going to give us 2 is less than x, which is less than 13. Next one. The ors. The good thing about the ors, you could treat them as 2 totally separate problems. It doesn't matter which one's true, as long as one of them is true. So I'll get x, subtract 8 from both sides. X needs to be greater than negative 2. Let me rewrite that so it looks a little better. X needs to be greater than negative 2. Or, and then pull the 6, you'll get x needs to be less than negative 10. Put that or inside the box. Kind of missed that. All right, fantastic. Sliding it up. Hannah loves gummy bears and wants to purchase some to take on her car trip this weekend. She knows that she will need 3 pounds in order to make the trip bearable, but only has $7. Write and solve the inequality to find the possible numbers per pound that she can spend if P represents the price per pound. So she wants 3 pounds, and they cost this much a pound. So if they were like $2, it'd be 3 times 2, that'd be $6 total that she spent. Now, she only has $7. So 3 times the amount per pound needs to be less than that $7. Solve your inequality and round your answer to the nearest penny. We'll take, divide that 3 off, and we'll get P is less than, it'll be 2.33, rounded to the nearest penny. She needs to pay less than $2.33 a pound for these gummy bears. How many problems we have left? We'll see if we need to make a third video. We will need to make a third video. We'll cut it here.